Good morning. We are dealing with water quality assessments and water quality parameters for its portability with drinking water standards. One is the pH value. When the pH value of water is less than 7, it is acidic. If it is more than 7, it is alkaline. If it's 7, it is neutral. You have pH meter to read the value of pH of any water from any water source. We have pH indicator papers also. That also will give you, according to the change in color, you can assess the pH value. Usually the value as far as Indian standards 10,500 BIS, Bureau of Indian Standards, revised in 2012, the value can be in between 6.5 to 8.5. 6.5 to 8.5. That is the allowable pH for portability.
One of the chemical parameters that we measure for water quality is pH. pH measures how basic or acidic the water is. It goes on a scale from 0 to 14. 7 is neutral. Anything less than 7 is considered acidic. Anything greater than 7 is considered basic. So for example, citric acid, like lemons, generally around a 4 on the pH scale, are considered an acid. A common base that most people know of is bleach, generally has a pH of 11. Just like you wouldn't want to drink bleach, fish, aquatic organisms, they don't want to have to live in conditions that are outside of a healthy range for pH. In Utah, the legal water quality standards are for all beneficial uses, are between 6.5 to 9 for pH. For our Tier 1 Utah Water Watch monitors, we use a litmus paper test that is on a scale from 5 to 10 pH. We'll show you how to measure this now. First step, remove one litmus pH paper. Don't make sure not to touch the colored end because then it can start to react with the oils on your hands. Go to your monitoring location, submerge the colored part under the water for 30 seconds. So that's what I'll do right now. All right, that's 30 seconds. Now you just want to shake it off. We're going to let it dry, let the chemicals react for 2 minutes, and then we're going to use our color comparator to compare what the pH is. So 2 minutes. So the next step is to compare the test pH strip to the known colors. You're going to compare all 3 colors. So this one is for a pH of 5. Obviously it doesn't look like that, so you can just kind of move it along as it moves up in half a unit increments, and you want to try to find the one that matches most closely all 3 colors. So when I'm looking at this right now, you want to look at an even lighting source, so either all shade or all sun. And I would say that this one most closely matches with a pH of 8. So that's what I would record on my data sheet, pH 8.0. So this is in our healthy range.
Another is the hardness of water. Hardness. As in school days, you would have studied the temporary hardness and the permanent hardness. The temporary hardness can be removed by boiling. Boiling the water, you can remove the temporary hardness. Hardness is the property by virtue of which the water may not be sometimes suitable for the aquariums, for fish. Hard water is not good. Hard water, very hard water is not good for potability too. Hardness is because of the presence of minerals such as carbonates, bicarbonates, sulfates of calcium and magnesium. Calcium sulfate, gypsum, then limestone, presence of limestone, then magnesium sulfate. All these things are coming to water when water percolates through the soil. Soil may be having these minerals, and water flows in a stream, it becomes hard because of this presence of these minerals. So hardness is another parameter. You have methods to find out the hardness. Soap water method, and another is EDTA method. In the laboratory, I told you yesterday one book, Standard Test Methods of Tests. It's a very thick book containing all tests related to water quality. Another is the total solids in water. Total solids. Total suspended solids and total dissolved solids. The total suspended solids such as dirt, small particles, those suspended matter can be filtered using a filter. Thus, this total suspended solids can be filtered and you dry in a oven for 24 hours. Then take the weight with the suspended matter is as residue in the filter paper. Knowing the empty weight of the self weight of the filter paper and this new weight, the difference is nothing but the total suspended solids. The filtrate, after filtering, you have the filtrate. You completely using a drying oven, dry up the filtrate. Once you dry up the water completely for 24 hours, you will get a residue on the filter. That is nothing but the total dissolved solids. So total suspended solids and total dissolved solids. You have values for all these things. Possible, I'll give you the table. If I get a table, I'll just put a table. Water quality, permissible limits. Then you have chlorides, nitrates, sulfates, then hard and heavy metals such as copper, zinc, aluminium, selenium, lead poisoning, very dangerous, lead, magnesium, manganese. So, all these presents very microscopic quantity, very less quantities. The permissible level itself is very less. But you have to test the water for all these presence of these metals. Then the radioactive alpha and beta. elements, alpha elements and beta elements, radioactive, presence of these elements. That also shall be investigated. Then the turbidity. Turbidity is in water the presence of turbid molecules, turbid particles. The water will be just like a slurry. If it is more turbid, it will be just like a slurry. So turbidity is nothing but the presence of sometimes organisms too. Usually the solid particles. You have turbidimeter to measure that. And the unit is NTU, nephelometric turbid unit. Nephelometric turbid unit, NTU. Turbidity. Then the bacteria, coliform bacteria and E. coli. Coliform bacteria and E. coli, their presence is a threat. E. coli means actually the water is being contaminated or even polluted because the presence of human excreta or animal excreta, and coliform bacteria also similarly. Usually this E. coli is more dangerous. That doesn't mean that coliform bacteria can be present. Both of them shall be nil. And regular water testing is required to rule out the presence of these two bacteria. Then the taste and odor. It should have an agreeable taste and odor. There's no objective units for taste and odor, even color. It should be agreeable. That's the word, the standard they are using. Odor and so pH, hardness, turbidity, total solids, coliform bacteria and E. coli, and alpha elements and beta elements. Then chloride, nitrates, sulfates, then heavy metals. All these presence have to be, and there are permissible limits. And for potability, the values have to be well within the permissible limits. So how we will conduct the test? There are testing kits. Then you have equipment also, such as spectrophotometer. Then you will be doing by the process of electrolysis. You can get the advanced tests, and by titrometric methods. Usually, as you do titration in the lab with using the reagents and indicators. Such as methyl orange and phenolphthalein. By titrometric method, you can arrive at these quantities of these, you can say contaminants, and their actual value. We have to test the tap water. Tap water has to be tested. Municipal water tank, you have water tanks, so source. That water, municipal water, has to be tested. Then open well. From the open well, the values have to be tested. Then bore well. When you tell bore well, the presence of fluoride, possibility of the presence of fluoride in bore well is more. So we have to test the water for fluoride also, especially when it is from a deep well. So fluoride, as you test chlorides, fluorides also have to be tested. Then iron, all types of metals, arsenic, presence of arsenic, cadmium, then radioactive elements such as uranium and plutonium. A detailed investigation of the water from the source, whether it is the water supply scheme supplies water to a residential area or to a town or a township. Whatever may be the case, if it should be potable, used for drinking, it has to conform to the available standards pertaining to the country. In Bureau of Indian Standards, it is 10,500. We have different parts, so different tests, part 1 to so on, for all the things which I have been listing so far. So you get the permissible value, and those permissible values will be the deciding factor if the tested water has the values well within the permissible limits. That is the water quality. And water quality assessment shall be done in frequent intervals. We have to do it. And if at all the water is contaminated or even polluted, necessary disinfection methods have to be followed and the water has to be made potable. Usually one disinfectant is the bleaching powder. Usually for bacteria, you use bleaching powder, a dosage of bleaching powder, in according to the amount of water to be disinfected. You will fix up the dosage of bleaching powder. Bleaching powder is one of the disinfectants frequently used to disinfect contaminated water. So, the water from any stream, in river, you will be using the water in the municipal water supply scheme, taking water from the river. Somewhere drinking water will be taken from a lake. So accordingly, the quality of water will change and the values will change. So water sources have to be decided and test has to be individually and independently done at frequent intervals for all water sources. And a ready reckoner, an evaluation register has to be kept to prove that people have been given potable water, satisfying or conforming to the permissible values of this foreign matter in water. Then you have mineral water. Water bottle is common, bottled water. So test has to be done and it should be confirmed whether the firm or the company will be claiming the values. Usually it will be in mg. Initially it was in parts per million, ppm. Now it is in mg per liter. mg per liter. So all values they have to list. And once tested, they have to satisfy their claim. Similarly, you have the reverse osmosis, RO methods to treat water. You have filter having sizes of micron filters. We have mandibles. There are companies which make treated water for potability. So the source, even though you are using this treatment, domestic treatment, RO method, the water after this process has to be tested and to be verified whether they conform to the claim of the company regarding the permissible values and the actual values water has. It should be a regular process of investigation, and water and air. Water and air are the two main sources or agents which is, if contaminated or polluted, spread the disease either by bacteria or by viruses or viri. So air and water quality assessment are very relevant as far as public health is concerned. We will continue by God's grace next day, tomorrow. Thank you. God bless.